Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be discussing unsteady flow, specifically boundary conditions. So what that means is if I go up to my HEC RAS here and I go Edit, Unsteady Flow Data, this is the dialog box that I'll be talking about in this lesson, specifically this first tab for boundary conditions. Okay, so let's take a step back real quick. I got my geometric data editor already populated here with a single river, single reach, a few cross sections, one inline structure, and a storage area. We can look at the details of those structures a little bit later if necessary. But yeah, like I said, we're going to go ahead and go edit and then unsteady flow data. And as you see from this dialog box, we have four tabs up across the top: boundary conditions, initial conditions, meteorological data, and observed data. So this video will be about just the boundary conditions tab. The user is required to enter boundary conditions at all the external boundaries of the system, as well as any desired internal boundary locations, and set the initial flow and storage area conditions at the beginning of the simulation. So that's what we're going to be doing here. We also have a description that you can add in as an option, but basically what we have in this table down below is a row for each location for boundary conditions. There's three different types we're seeing here. The cross section here at River Station 2000 up at the top of the reach, the cross section at River Station 0, and then I also have this inline structure here at River Station 500. So these are different types of boundary conditions, and we'll see how that works in a little bit. If I click on the upstream boundary condition at River Station 2000, you see my options up here for boundary condition buttons have become enabled, specifically the stage hydrograph, the flow hydrograph, and stage/flow hydrograph. If I select the downstream reach, I got a few different options, and then the inline structure, I have a few options as well. And if I add another river station, River Station 1000 here, this cross section right here, this is internal. So I'll go ahead and double click, add that, click OK. And then when I select that reach, I have a few of the other boundary condition options which weren't available to me with the other types. Okay, let's go ahead and get started with the flow hydrograph. So I have this upstream boundary condition selected. I can also go downstream, it's also available. But I'll start with the cross section at River Station 2000. Click on Flow Hydrograph. And now what I have here is a dialog box that gives me a lot of different options on how to set that flow hydrograph boundary condition at that upstream most cross section of my model. The two main radio buttons to first consider is right here: either read the data from a DSS file or enter the data manually. If I enter the data manually, then I have to enter all this data down here. If I enter it from a DSS file path, then all I do is enter the file and the path. So let's go ahead and do that first. It's a little bit quicker and simpler. What we're going to do is select this DSS file and path button. Before I do that, I'm going to bring up DSS view and then show you the file that I have prepared for this lesson. Okay, open. Okay, it's right here, data.dss, and open. I have a few different paths here. For instance, we have flow versus time, stage versus time, and then flow stage, which is a rating curve. This is just data that I made up. This is not part of HEC RAS per se, but it will be imported into these unsteady flow boundary conditions. So what I'm going to do for the flow rate is I just created a dummy flow rate record right here. Here is the data in text. It has a 15-minute time step, and you can see the values in CFS. Also, here is a plot, which I just created. So anyway, that's what the data looks like. So back to HEC RAS here, I'm going to click this Select DSS File and Path. And I already have this selected from preparation, but this is what it'll look like when you open it up the first time. There won't be any files or paths listed. But what you'll do is you'll click on this button here to add a DSS file. You'll navigate to that DSS file. Okay, I've navigated to that same data.dss file. And once that's selected, I have the different paths down here. I can use the filter tools if I had a lot of paths, but there's only 3, so it's pretty easy to find. I'm looking for a time series on my river reach. Here's the flow rate, and then I have the start date time and the interval. and then the type and the units. So I'll go ahead, have that selected. I'll go ahead and click OK. And boom, that's all I have to do. It's populated the file path as well as the path name. So that's how to import the flow hydrograph boundary conditions using a DSS record. Actually, I think also if I plot the data, yeah, so I see that same data plot right there. And then I think I can also plot the data from in here. Show a plot. Yes, there's the data if you happen to want to see a plot. Okay, anyway, let's go ahead and select that flow hydrograph again. I closed it. There we go. I'm going to select enter table. So this is the manual entry. And let's see. So we'll select the start time and date. Now, if I have this radio button here for use simulation time selected, what's going to happen is it's going to just start the flow hydrograph data at the same date and time that the simulation starts. So I don't have to worry too much about the exact date and time, but what I would care about is the simulation time when I enter in the flow data. So let's just go ahead and enter in some data manually. I'll say 200, 250. Okay, just making up some numbers there. This is the flow rate in CFS. And then with simulation time, it would just start immediately on that first hour with the 200 CFS. And then looks like the time interval is 1 hour. So if I switch the time interval to something else, say it's 2 hours, then the values for flow did not change. But what did change was the simulation time. And it looks like by default, it's starting at January 1st, 1000 as a year. So that absolute time has also been adjusted based on our change of the interval. I can change it to 6 hours, and then we see the numbers change over here, but not the flow rates. All right. So if I wanted to use fixed start time instead, I would click fixed start time, and then I would enter a date. I think I can, yeah, I can type in a date or I can use this calendar date picker. So I will say this starts at the beginning of this year, which I'm recording this in 2024. And then I will just navigate to the month, January 1st, and double click. Okay, just click OK. Okay, looks. So it just populated right there. I think I could have just typed it in. It would have been faster, but that's fine. And I'll say this starts at noon, 12 o'clock, and I'll change the interval to, let's go to 15 minutes and see what that looks like. Okay, so we have the dates populated and updated here, noon on January 1st of 2024, starting at 0000 hours. Let's see, I put 12. Oh, I'm sorry, this is simulation time. So it starts at noon, 12:15, 12:30, 12:45, and then this is the simulation time. So sort of the cumulative time since the simulation has begun. As you notice, the flow record, the values for CFS have remained the same. All right. So if we wanted to change the flow records, then we can use some of these buttons right here. Number of ordnance is the number of records. So I can change that if I wanted to. Enter the maximum number of ordnance. If I wanted to just make it 20, I think the minimum is 100. Yeah, so it's told me the maximum value is 100. So, but I could change that to 200, click OK. That just gives me more rows in this table right here if I need it. All right, interpolate missing values. So what that looks like is I will delete some of this data. We'll say the 0 hours is 200. We'll say this is 400 half an hour later. So 15 minutes should be 300. And if I click this value, boom, it adds 300 right there. Okay. I can also delete a row or insert a row. This pertains to just the flow column though. So for instance, if I take this 300 and I click delete row, it just deleted that one row, but only for the flow column. Didn't touch the date column or the simulation time column. And then if I want to insert a row, same thing right there. I can type in my data. Down below this table of data, there's a few other form fields that need to be described. First of all, there's this monitor the hydrograph for adjustment in computation time step. If there happens to be large changes in the flow between two time steps, that can cause instability during the compute phase. So to prevent that instability, the user can specify max change in flow. And if that's triggered, then what will happen is it'll split that time step into half the time and then half the flow change. So for instance, if I had 200, 300, 400, and then 800, and I said that I had this checkbox checked right here for the time step critical boundary. Next, I'd have to specify the maximum change in flow, and this is between two adjacent time steps. So for instance, I felt like my model was going to become unstable if in a 15-minute time period, the flow changed more than 300 CFS, then I could type in 300 right here, and it would not affect either of these three time steps, but between 12:30 and 12:45, we have a change of 400 CFS that exceeds 300 CFS, then that time step would be divided into two halves, and same with the change in flow. Okay. Further below that, we have a minimum flow requirement right here. So if I said the minimum flow in this channel happens to be something like 250, then any value like 200 below 250 would automatically just be changed to this specified minimum of 250. That's a way to prevent instability, and it kind of works the same philosophy as using pilot channels in the geometry file as a way to just minimize the instability during low flow situations, since typically during HEC RAS, we're more interested in high flow scenarios anyway. All right, the multiplier right here would multiply the values in the flow column by whatever value is selected. So if I wanted to double the values, I'd put a 2 right there. But if you just set it at 1 or leave it blank, it would just be the original values you're seeing. Okay, so I'm going to go ahead and click OK. What we now have in our main boundary conditions tab here is flow hydrograph. So if I ever wanted to look at that again, you can just double click and it will open up, and then click OK. Or you could just click the flow hydrograph button again. There's the data. This data actually should appear on the plot with, yeah, so this is the new plot based on that data I typed in 200, 300, 400, 800. But if I went back to the DSS data and clicked plot data, I'd see the DSS data. Okay, it looks like it has the minimum flow right there built in. That's cool. So click OK. Now we have a number of other buttons to talk about. So that one will take the longest. The rest will be a little bit quicker because you'll notice that these forms in the boundary conditions that are behind the buttons share a lot of the same properties. So for instance, if I clicked on stage hydrograph, it first gives me this warning to say, are you sure you want to use stage hydrograph? All the data from flow hydrograph will be removed and overwritten. So I'm going to say, yes, I understand. And now what we have for stage hydrograph is, as I mentioned, a similar interface. So I don't need to talk about it too much. As before, I would set the DSS data not to flow, but to stage. So I do have a separate record for stage. Let me go ahead and uh, there it is. There's the stage versus time. So I'll click apply if I was using stage data. But so that's how to set the stage. If I wanted to do a manual entry, there's no difference here between what we saw with the flow hydrograph. So we have the stage hydrograph. We'd specify if it's using simulation time or fixed time. And then all these buttons are the same. A few of the controls at the bottom are no longer there. But we have the stage data in feet instead of the flow in CFS. The same buttons and tools and time interval drop down as before. Okay. The third and final button that's eligible for us to use for a boundary condition at this upstream cross section is stage/flow hydrograph, and I will say yes to overwrite. This is sort of a combination of the two but now we have a column for stage data and flow data, and then these hydrographs or this inflow data can be used together. All right, next down I'm going to click on this cross section here at the bottom at river station 0. And what we have now is options for rating curve and normal depth, which are not available for the upstream-most cross section. So if I click on rating curve, this can be used as a downstream boundary condition. As mentioned before, we have an option for DSS records, and we also have an option for manually entering a rating curve. I believe I did also prepare path for rating curve. This would be a paired data set, and it knows that as well. So it automatically set the filter to paired data, but that's fine. So this is my data. Here is the plot of the rating curve. It's very incomplete, but I just want to put some numbers in there. So I'll click OK. So that's how that would happen. If I wanted to manually enter the data, then I can do that. I could just say 30 feet is 0 flow, 31 feet is 400 CFS flow, 32 feet is 900 CFS flow, and so on. That's probably not correct, but whatever. We can delete rows and insert rows. And anyway, that's about it. All right, so I'll click OK. Normal depth is another option for us to set for our boundary condition. Again, I'm on the cross section at river station 0, so I'll click OK. The normal depth option can only be used as a downstream boundary condition for an open-ended reach. And what we're expected to input here is the friction slope. Now, you may not know the friction slope, or in this case, the energy grade line slope. So it's safest to probably just use the slope of the 002 of the bottom of the channel. And then there are a couple grayed out options down here for 2D flow area boundary condition parameters. I have a storage area on my map, but not a 2D flow area. And the user's manual doesn't say anything about this option anyway. So I'm just going to go ahead and skip that. There will be a few other times in this lesson where the level of detail sort of exceeds the level of detail I want to talk about in this very first lesson about unsteady flow. Now, right here, I have this river station 1000. If I wanted to delete this river station, I can go up to options and then delete boundary condition. And then let's see. So yeah, that's the one I want to delete. I can click OK, and then it's gone. But if I wanted to add it back in, I can click Add River Station. I think I've already done this at the beginning, this one right here, and then click OK. Okay, so I've got two for the inline structure. I don't need that second one. Options, delete the boundary condition. Yeah, that one right there. Okay, and then let me go ahead and add the boundary condition area for the storage area. So there's a storage area right here on our map. Then arrow over and click OK. So that's got its own area down here. Okay, the reason I added the intermediate cross section here at River Station 1000 is because this gives us the option to include lateral inflow hydrograph, uniform lateral hydrograph, groundwater interflow, as well as the IB stage flow, the internal boundary conditions, which is not upstream or downstream. Okay, so let's go ahead and check these out. So with that 100-foot cross section selected, I'll click on lateral inflow hydrograph. This is an internal boundary condition, which is why it wasn't an option for the 2000 or the 0 river station cross sections. As before, we can specify a record, a DSS record, or we can specify a lateral inflow flow rate right here based on all the same tools that we saw when we were looking at the flow rate, the flow hydrograph button. This boundary condition allows the user to bring in flow at a specific point along the stream. And then I'm going to click OK. The difference between this lateral inflow hydrograph and uniform lateral hydrograph is, okay, that this lateral inflow hydrograph basically brings flow in through a hydrograph along a reach of a stream, not a single point. What the user manual says is that this boundary condition for uniform lateral inflow hydrograph allows the user to bring in a flow hydrograph and distribute it uniformly along the river reach between two user-specified cross-section locations. So everything else is the same here, except we are going to see this label at the very top that says inflow will be evenly distributed between River Station 1000, which is the one I've selected, and then it gives me a drop down to what I assume would be all of my other downstream cross sections. Now, I only have one other downstream cross section, which is at River Station 0, so that's the only one I have to select, but it would be able to give you that flexibility. All the other controls that you're seeing here are the same as the original flow hydrograph. Okay, I'll close that. Next up, with the 1000 cross section still selected, I'm going to click on groundwater interflow and click yes. This has a lot of similarity with the previous option, which was the uniform lateral flow hydrograph, except this time the groundwater boundary condition can be applied to a river reach or a storage area. So if I click on storage area right here, I still have the groundwater interflow option, but we're going to go with the river reach that's internal. Okay, so let's bring that up. What happens here is the user will type in the groundwater stage in feet. So this is an elevation value for each of the time steps. And of course, you have the same controls with interval and start time and so on. And then you would also, as the user, specify the hydraulic conductivity and the thickness, or rather the distance from that groundwater stage to the element of interest, whether it's a storage area or a river reach cross section. After that, HEC RAS will run the calculations and determine what the flow rate is, which direction, and the quantity as well. So magnitude, quantity, and direction. This hydraulic conductivity is in feet per day, so you'd go ahead and insert that data there, and that would be the average hydraulic conductivity between the location that the groundwater stage was measured as and the either the storage area or the river station. And then this distance here would be that distance as well between those 2 points, which is used to determine the gradient and hence the overall flow rate. So we have minimum flow and multiplier for the data. We saw those tools as before. So we'll click OK. The next option is time series of gate openings or TS gate openings. That's this one here. It's grayed out. So what I need to do is that would apply to inline structures. I have an inline structure right here at River Station 500 on the map in the geometric data editor. Yeah, I can bring that up. It shows 3 gates right here, all part of the same gate group. So that's important because when I select TS gate openings, what we have is an interface that allows me to specify height that gate is going to be open at each time step. Now this is a 1 second time step, it appears, but I can change that to something maybe a little more realistic, like 1 minute or 10 minutes. And then you can see that the values in the 2 left columns for date and simulation time update when I change that date time interval. I can also specify the gate opening height with the DSS file as before, or do the manual entry as you can see. And then some of the tools like number of ordinates, adding and removing rows, and interpolation are also available. Okay, so I'm going to close that one. The next one over is elevation controlled gates. This option allows the user to control the opening and closing of gates based on water surface elevations at different locations in the model. And what that location is controlled by this reference dropdown right here. So I should probably back up and first say this is pertaining to the River Station 500, in particular gate 1. So I have one gate group, but if I had multiple gate groups, then I would change that right here. And then the reference that I mentioned, we have 3 options. It's either based on the upstream water surface elevation at that inline structure, or it's based on specified reference, so somewhere else in the model, or the third option is to be based on the difference in stage between 2 different references in the model. So let's start with the first one just to keep things simple. It's going to be based on the upstream water surface elevation at that inline structure. And then what we would do here is type in the elevation at which the gate begins to open. So I'm just going to type in some numbers. The water surface elevation at which the gate begins to close. I'll say 46 feet, for instance. And then down below here, we have some controls that are consistent for all 3 reference options. And that pertains to the rate at which the gate opens and closes. So something like 1 foot per minute, for instance. I'm not sure if that's a lot or a little, but you don't want it to open or close too quickly. The maximum gate opening here, I believe, is 10 feet. I can go ahead and check that out. So inline structure, and then we have the gates. And then, yeah, so the height of the gate fully open would be 10 feet. Let me close this. And then, oops, where am I? Okay, there we go. So back to 10 feet is the max opening. The minimum gate opening would be 0. That means it's a closed gate. And then the initial gate opening would be, it's optional, but you could just start with it closed. You could start with it fully open. You could start with it, 5 feet, whatever. Okay, so that was the upstream reference. If we wanted to base the controls on some other reference, we just say specified reference. And then in this reference, this is where we go ahead and set either a river station or a storage area. So if it's a river station, I just click river station and say 2000, 1000, or 0 as my river station, because those are my set cross sections. But it looks like I can also change the river and the reach. Now, I only have one river and one reach, but you can imagine how some of these controls can get pretty complicated if the gate at this river reach is dependent on water surface elevation in a different reach at a specific cross section. So I didn't set that, but it would appear right here if I did. And then the third option here is based on a difference in stage. So this would be the difference between one reference point and a second reference point. And again, I can set it to a river cross section or a storage area. Then I'd also specify when the gate begins to open and close based on the difference between those two, the elevations at those 2 reference points. Okay, so that's how that works. Navigation dams is the next one. So I'll click on that. I'll click OK. This option allows the user to define gate settings, flow monitors, hinge controls, and minimum pool operations using some of these tabs right here as an advanced way to control inline gated structures that are used to manage the water surface elevation in the reach. Now, this is a little bit too complicated and beyond what I want to talk about in this very first introduction lesson about unsteady flow and boundary conditions, but I will most likely have a separate lesson on navigation gated controls because as you can see, this can get pretty complicated pretty quick. There's also a rules editor right here. And same with the navigation controls, this can get pretty complicated. What you do is go ahead and set up some rules by entering or editing the rule operations. And as with the navigation controls, this is a little bit beyond the level of detail I want to cover in this lesson. This is just an introduction, and I will most likely have a separate lesson or exercise covering operation rules as boundary conditions. But for now, I'm just going to click OK and let you know that this is an option. And there's lots of information in the user's manual about how it works. All right, the last one here is precipitation. Actually, I think I have to click on storage area. Yes, if I click on storage area, I can now set precipitation. This is a precipitation over a specific storage area. So it would add volume of water over a certain storage area, whichever storage area we selected, with a incremental precipitation in inches added right here. So that would, of course, affect the flow and the hydraulics of the system. This option allows the user to enter precipitation hydrograph to either a storage area or a 2D flow area. It's incremental storage data. There's no spatial variability, but if you do desire spatial variability, there's a separate tab right here in the unsteady flow data for meteorological data. So that's also beyond the scope of this lesson. So once we have our boundary conditions set, we're going to go up to File and then Save Unsteady Flow Data. This is going to prompt us for a lesson or a title for this file. I'll call it Lesson 23. That's what I was thinking. And then what it's going to do is it's going to create a Lesson 23.u01 file. So I'll click OK. And I think that's saved, so I'll close this. And now up here in my files, I'm seeing Lesson 23 and then Lesson 23.u01. I can find that file in the rest of my project files right here. It's lesson 23 u.01. You're probably not supposed to open this up, but what we see here is the flow title, the program version I'm using, and then after that we have the different boundary locations. So for instance, at River Station 2000, we have this information right here. As you can see, it's got the DSS path and file name. And then we also have another boundary location here at cross section 0. We have that inline structure right here at River Station 500. So a lot of this data is just default or blank. And you probably shouldn't touch this data anyway, but it's good to know that that file was written properly and can be used when we go ahead and run our unsteady flow simulations. So that was it for this exercise. We talked about the Edit Unsteady Flow Data Editor, and we specifically talked about the boundary conditions and talked about all these different buttons, how they would be used as a brief overview and introduction to boundary conditions in unsteady flow data in HEC RAS.